Okay, question number 1. We have integral within limit of 0 and 2. Absolute value 2x minus 1 dx. All right. So first of all, let's understand absolute value of 2x minus 1. It's equal negative 2x minus 1 positive 2x minus 1, right? Now, how much is the x in these cases? So since we have between 0 and 2, which means in both cases it's going to be more than 0, yes? And plus absolute value, it come out positive anyway. That has to be more than 0. Therefore, to do drafting, it's going to be negative 2x minus 1 is greater than 0, and also 2x minus 1 greater than 0. So, and what we get here, negative 2x is greater than 1, and x is less than negative 1/2. Yes? So in this case, we are getting x is less than 1/2. Let's see what we get in this case. 2x is greater than 1, x is greater than 1/2, which means here we get x is greater than 1/2. So it looks like it's 1/2 is the point where it's split, separate negative part from the positive part. So let me show on the graph how it will look like. Okay. So this is my 1/2. This is my 1. 1, 2, 3, 4. This is going to be 2, right? 1, 2, 3, 4. This is 1. 2, 3, 4. This is 2. 1, 2, 3, 4. This is going to be 3, it looks like. Okay. 1, 2, 3. And our splitting point is 1/2. So this is gonna be my negative 2x minus 1. And for the positive part, 2x minus 1, let me plug x is equal to, see, that's our limit. So if I plug here 2, it's going to be 4 minus 1 is 3. And that's how I'm going to go. 2 and 3. Yes? And my graph will go through that point. Excuse me. There we go. Okay, so what do we have? This is our 1/2, and we have only positive part because it's absolute value, and positive part of 2x minus 1 also. And we are going to shade, we are going to integrate, find area between 0 and 2. This is this part, and it's gonna go like this. Yes? All right. So this pink color area, that's what we need to find. All right. So let me make it smaller. Taking too much space for one small picture like this. Okay, this is much better. And what we are going to have, so we are going to break down integration between 0 and 1/2, right, for negative part, correct? And then we're gonna have negative 2x minus 1 dx, and then plus 1/2 till 2. Yes? And it's going to be positive 2x minus 1. Okay. This is going to be equal negative 2x squared, or negative x squared. Again, as always, I'm trying to jump. Let's go slow. 0, 1/2, negative 2x dx. Okay, well, it's going to be plus, right? Because negative sign in front. 0 to 1/2 is going to be 1 dx plus 1/2 till 2, 2x dx, and minus 1/2 till 2, 1 dx. I just put 1 just for the heck of it, so you will see this 1 is there, but you don't have to put it. Okay, it can be just dx. Okay? It's entirely up to you. Okay. Took it off. Next. So this is going to be equal negative 2, the integral of x squared of 2, right? Which this will be gone, correct? And we need to plug limits 0, 1/2, and then plus, it's going to be x, right? 0, 1/2. It's going to be, again, 2x squared over 2. This is gone. It's going to be 1/2, and here is 2, and minus 1/2 and 2 dx. Hold on. Minus x 1/2 and 2. And we have negative 1/2 squared, right? Minus 0, obviously. 0 I'm not going to put. Plus 1/2 minus 0 again. Plus 2 squared minus 1/2 to power 2. I'm right here. And minus x 2 minus 2 and plus 1/2 because it's minus, right? So it should be minus 2 minus 1/2. And I just open parentheses right away. All right. So let's count it, calculate, rather saying. We got how much? Negative 1/4 plus 1/2 plus 4 minus 1/4 minus 2 plus 1/2. Okay. Let's see. Negative -4 and -4, right? It's gonna make -1/2, right? Okay, 1/2, it's gonna make 1, and 4 minus 2, it's gonna make 2. So it's gonna make 3 minus 1/2, it's gonna be 2 and 1/2, which is gonna be 5/2. Okay, we are done with this one. Moving to next one. Next, it's gonna be question number 2. We need to find the area of the graph bounded by the graph of y is equal to x squared minus 3x plus 2. By the way, I just want to let you know, integral calculate area, integral calculate volume. I guess I will create a video once I finish this. I need to create video overview of integral to explain to you what for we use integral, when do we use integral, just so you know, and might as well create an overview video so you would know when do we use derivative, in what cases, and when do we use double integrals, when do we use double derivatives. This is all I am pretty sure will be interesting, and so you can put voice to face, meaning knowing how to solve, you will know when to apply, when to use it. So because there are also double integrals, we will go through it, but when to use it as an engineer. So that's I will explain, and I'll put as a first video in the playlist. So first you would understand what and how and when, and then start solving these details. I'm a little bit late with this. I should do it first, but okay, I'm also human, so missed it. So, but I'll create that video. Okay, so we need to find the area of the region bounded by this graph. Y is equal to x squared minus 3x plus 2. Give me a chance to draw this graph. I'm going to do my best to make it look like it the way it's supposed to look. All right. So let me mark down points. So when x is 0, it's going to be 2. So if this is 1, this is going to be 2. It's going to go through this point. Okay, vertex is going to be a little bit approximately, I'm doing a little bit less than 1. I'll tell you what, let me take a wider size so we can see. 1, 2, 3, 4. I'll take like that. 1, 2, 3, 4. So we can see better. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So one point is going to be at the point of 2. Because when x is equal 0, it's going to cross these 2 right here. Okay, vertex, it's going to be a little bit less than 1, somewhere at point 1 and right here. It's going to be vertex approximately. And when x is equal 2, I think it's going to be equal 4. Let me see. Why am I taking 2? Because our x is going to be, we need to integrate between equals 0 and 2. Okay? That's why I'm going to take 2. So 2 times 4 3 times 2 plus 2. 8 minus 6 plus 2. It's going to be 4. So when it's... Okay, good luck with that. This is 2, 1, 2, 3, 4. This is 3. 2, 3, 4. This is 3, 1, 2, 3, 4. This is 4. Okay, so when it's 2, it's gonna be 4. Okay, so this is how it's gonna look, the graph. Well, not bad. Okay. Not bad. Okay, that's what we have. All right, so what we need to do, we need to find the area between 0 and 2. That's what we need to find out. The integral always find the area under the curve. Okay. I have it. More or less, it's all right. Okay. So this is what we need to find out, the area. Let's start working. Or I can write down also 0 and 2, right? Either way. So what does that mean? I'm going to take integral because I'm finding area. It's going to be between 0 and 2. And I have 2x squared minus 3x plus 2 dx. Okay? So this is going to be, let's solve it. I'm going to break it down, so it's might as well 2x cubed over 3, 0, 2, minus 3x squared over 2, 0, 2, and plus 2x, right? 0 and 2. Okay, so we have 2/3 times 2 to power 3, and since low limit is 0, I'm skipping because times it's gonna be all 0, minus 3 over 2, it's gonna be 2 squared, low boundary is 0, so I'm skipping, and plus 2 times 2. So what do we have? We are getting 2/3 times 8 minus 3 over 2 times 4, 1 and 2, and plus 4. So we have 16 over 3. Now I would like to talk about average value of function, average value of the function. Sometimes we need to find out the average value, which means not to go for entire area via integral, but just find out the average value. So let me do a little bit explanation. Let's say this is my graph. Let me write down average value. Of a function. Okay, so let's assume I have such function. Yes, this is function f of x. I'm not going to go into lecture. I'm just giving you idea and to help you to understand, and then we will solve it. All right. So this is, let's say, we need to find the average value of the derivative on the area, in the area between A and B. What do we mean when we talk the average value? Because derivative, it's measuring it's the instant speed, right? Because when you are driving and your foot on acceleration, it's on every moment of the given time, you have different speed, correct? So if we want to find out the average, so we're going to use derivative. So on interval A and B, this is going to be value of f of B, and this is going to be value of f of A. And the average of the derivative, which is average of the instant speed, average of the speed, it's going to be average of f of x. It's going to be equal f of B minus f of A over B minus A. Yes? Now, but this is the average of derivative, average of the speed. Now, if I want to find the average of the function itself, okay, average of the function itself, here we are going to take antiderivative in the point of B minus antiderivative in the point of A and divide by B minus 8. So which we have A over B minus A, and antiderivative B minus antiderivative of A, it's gonna be integral from A to B f of x. Right? It's the same thing. Okay. So we are trying to find average value of function itself, not the tangent line, not derivative, but of the function, original function we have. All right. So let's take an example. How we are going to work out. Let's say we have y is equal sine x. And I need to find the average value of the sine x on interval between 0 and p. Okay? So we know that integral of sine x dx from 0 to p to pi is equal negative cosine x plus c, right? So which means it's going to be equal negative cosine pi minus negative cosine 0 degrees, right? Okay, cosine pi, where is our pi? This is our pi, this is 0. Cosine pi is going to be negative 1, right? With this negative in front, we have positive 1. Cosine of 0, it's going to be positive 1, right? So it's going to be minus negative 1, and we are going to get 1 plus 1 equal 2. Now, what is going to happen with the c, constant c? Here is what's going to happen. If I take, let's say, antiderivative f of pi, it's going to be equal 1 plus c, right? Because cosine pi, it's going to be positive 1. And f of 0, antiderivative, which is negative cosine of 0 equal 1. But because we have here negative cosine 0, we are going to get negative 1, right? Okay, and this is this negative 1. And plus c, okay? So now we need to subtract, right? From 0 to pi, so f of pi minus f of 0. The constant is gone. And we are getting 1 minus negative 1, which is equal 2. So when we calculate the average, we are not going to use constant because constant is going to be gone, just like here. Next, to find the average, what do we have to do? Finish it up. The average is going to be, which is average of f of x, right, is equal antiderivative of b, which we have, it's pi, f of pi, minus antiderivative of 0, which we have f of 0, divided by b minus a, which we mentioned, it's going to be same thing, 1 of b minus a, integral from 0 to pi, f of x dx. Yes? Okay. So we have f of b minus f of 0, correct? So our f of x average, it's going to be equal to f of b minus f of 0, we have 2, divided by b minus a, which is pi minus 0, and we are getting 2 over pi. All right, this is going to be our average, 2 over pi. Now let me show you on the graph. Let's say this is our sine. This is obviously it's going to be 1. This is going to be how much? It's going to be pi over 2, right? So pi over 2, it's going to be how much? It's equal 3.14. If I want to calculate this way, 2, it's 1.5 and blah, blah, blah. Let me see, 10, 14, 1.7, so approximately 1.6. Yes, this piece, 1.6. And our average here is going to be 2 divided by 3.14. It's going to be approximately 0.63. So 0.63, if this is my half, so it's going to be approximately this is going to be our average, right? This is going to be our average. Now, you might wonder if half of 1 is 0.5, but that's for straight line, right? Since we have here curve, right? This is 0.5. Because we have here curve, then it's going to be a little bit more, correct? Okay. So the average for this, average for y is equal sine x on the interval from 0 to pi, it's going to be about 0.63. Moving to next question. Next question we are going to have, it's going to be find the average value of the function y is equal natural logarithm x on interval 1, yeah, okay, 1e. Okay, so we are going to take integral from 1 to e natural log x dx. Using method of substitution, we are going to get x ln x and minus x. Whoever doesn't know or remember how to do method of substitution, open my videos with method of substitution, and I believe you will find something very similar or exactly maybe logarithm x also, and it will be easy for you to figure it out. So this is what we get, and we are going to have, let me see, I can take write down as an antiderivative from e. It's going to be x times ln x, okay, e times logarithm, natural logarithm e. Okay, let me write down like this, e and minus e, right? It's going to be e times natural logarithm e is 1 minus e. It's going to be 0. Now, antiderivative of 1, it's going to be 1 times natural log 1 minus, natural log of 1 minus 1. It's going to be 1 times any logarithm of 1, it's going to be equal 0, and minus 1, right? We are going to get, this going to be 0, answer going to be negative 1. And because we need to subtract one from another, right? 0 minus negative 1, we are getting positive 1. So this is going to be our top portion. Let me see. This is going to be our f of b minus f of a is equal 1. So average of x, it's going to be equal 1 divided by e minus 1, yes, divided by b minus a, correct? Okay, and this is going to be equal, if you calculate, it's going to be approximately be 0.58. So why 0.58? Because 0.58 because e is equal 2.71828. If you divide, you will get the result. And e, we sometimes it's called a natural number or Euler number. Euler number. It's an important mathematical constant. Okay. So what we're gonna do next? 0.58. Let me show you on the graph. So if this is gonna be 1, where it's crossing, when x is 0, it's gonna be here 1. Here, let's say it's gonna be e. So it's approximately, it's gonna go like this. No, I don't like it. Has to be curved. Okay, well, approximately something like this. All right, so if you look at it, you will see that the half of it is going to be, again, it's going to be about 1/2, right, if you provide straight line. Yes, but because we are using curve, we have curve, therefore it's going to be a little bit above, okay, and that's going to be 0.58. All right, moving to next question. Solving next one and the last one. okay? And well, let's say we have y is equal tangent x, okay? And we need to find the average of tangent x on interval 0 and pi over 3. All right, so this time I'm taking first indefinite integral tangent x dx, and then I'll do antiderivative. It's not a big deal. Tangent x dx. I'm just using all different methods of approach, so you'll get to see it. So we are getting here integral sine x over cosine x dx. So this sine x I'm bringing under the derivative, and I'm getting here integral d cosine x over negative sine here, obviously, over cosine x. And we are getting negative natural log from cosine x. Okay, let me see. I would like to draw the graph of of tangent x, natural logarithm of tangent x, and let me see. This is 0. Here I have pi over 3. Okay. $1.7. So if you have calculator or on internet, you can find a table that will calculate for you how much it's going to be tangent of pi over 3. Okay. Hold on, let me draw this. Okay, this is 0. So we would think that approximately it's going to be, the average is going to be 1.7 divided by 2, which is going to be 0.80 something, right? 85. So, well, let's see. Antiderivative, I'm going through antiderivative. Antiderivative for pi over 3 is equal negative logarithm cosine pi over 3 it's going to be equal negative logarithm 2 to negative 1, right? Because it's a cosine cosine pi over 3, it's a 1/2. I put 2 to negative 1, which is going to be negative come in front, negative 1, and logarithm 2, and that is equal positive logarithm 2, right? So this 2 to negative 1 is not a big deal. Cosine half pi over 3 is 1/2. 1/2 is a 2 to power negative 1, okay? So you won't wonder. And then antiderivative of 0 is equal negative natural logarithm cosine of 0 is equal negative log 1, which is going to be 0, right? Because any logarithm of 1 is 0. And the average is going to be is equal f of x average, which is equal logarithm 2, right? Divided by pi over 3, or pi over 3 minus 0, right? B minus a, and this is equal logarithm 2 divided by pi over 3. This is going to be equal 3 natural logarithm 2 divided by pi. And if you plug in the calculator, pi 3.14, 3 logarithm 2 calculator, use calculator, accordingly it's going to be 0.66. So as you can see, our approximate calculation of how much was that, 85 or something, but it doesn't work. So visually we cannot always figure out how much it's going to be. And 0.85, which half of 1.7, here it's much lower, 0.66. Okay, so which means we always gonna need, when we are trying to find out the average value of the function, we always gonna need the integral on the integration on the interval. We need to find the average value. Okay, I think that was an interesting topic. Well, but it's my opinion only. So thank you for watching, and I'll get some video again.